Hi friends, again I am coming with the kinetic energy biological physics classes. Please subscribe and like and listen very properly. See, now I am going to discuss with you kinetic energy. What do you mean by kinetic energy? Kinetic energy is defined as when an object is in a motion. By virtue of its motion, if the object is possess some amount of energy, that's we call it as kinetic energy of that object. So simply I can write as kinetic energy is defined as the energy of a body by virtue of its motion. The energy of a body by virtue of its motion. Since it is in motion, therefore it possesses some amount of energy. If it is not in a motion, it will not possess such amount of energy. That's we are talking about kinetic energy. The kinetic energy is a measure of work a body can do by virtue of its motion. So, every moving body possesses kinetic energy. You know that. If I'll hit with a stone to somebody, they'll get hurt. It means energy has released there. For example, let us see. A moving cricket ball possesses kinetic energy because if you go against that or opposite to that, you will get hurt, right? Nice animation you're seeing. If you're not taking into hand properly, what happens? The ball will repel back or recoil back, and at the same time, the hand also will get some pain or hurt due to this ball because it's releasing the energy, right? Now we have a formula of kinetic energy. Since an object is in a motion, due to motion it is possessing in the sense, we know that the characteristics of motion is a velocity. So the object must have some velocity. Object itself is having some mass also, right? That you can see here. Suppose a body of a mass m moving with a velocity v or u is acted upon by a force F for a small interval of time, then let v be the final velocity of an object. The object has displaced some distance in the given time or at the end of the motion. So, in such case, in this process, we have applied force, therefore, we have done some amount of work, right? So, when you have applied force on any object, that means object has displaced. So here object already is in motion with some amount of velocity. Object is already is in motion, but due to application of force, the velocity has been changed from u to v. Okay, that nothing but we will write work done equal to force into displacement from the work definition. Work equal to F into S is a displacement. Force into displacement. We know that force, according to Newton's second law, is product of mass and acceleration due to gravity into displacement. So I'm taking this is as a equation one, but in this I wanted to find two things which is I don't know, that is acceleration and displacement of an object, how much it is. So for that purpose, I have used, since the object is in motion, to find the acceleration and displacement, I am using equations of motion. With the third equation of motion, with the help of third equation of motion, now I'm gonna find the acceleration. Look at here. V square minus u square equal to 2as, I know. So from this, what I'm doing, I'm making as a subject. Therefore, A is equal to half v square minus u square I can write. What I'm doing this AS which I need to substitute in equation 1, therefore I'm substituting in the equation 1. So I have an equation work done equal to, after substitution in equation 1, work done equal to, you can see here, m into 1 by 2 into v square minus u square. Nothing but this equation, if I'll rewrite, half m into v square minus u square. If I multiply inside, it will be half m v square minus half m u square. Listen here. The work done is possessed by the body in the form of kinetic energy, right? That I can write kinetic energy equal to half m into v square minus u square. Let us say if I'll take the body is started from rest, or the body has stopped by some obstacle, then one of the velocity will be zero from this expression. Then I have kinetic energy equal to half mv square. Okay, so if the body is initially at rest, its final velocity is v, then our equation kinetic energy equal to half mv square we can write. This is a proof of formula for kinetic energy. See, you can understand from this equation, kinetic energy depends on the mass of an object as well as square of the velocity of an object. If more the velocity, more the mass. Okay, and at the same time, if an object is always depends on its motion here, right? So these are the factors which affects the kinetic energy always. Thank you very much.